Again, this is all pretty much a review. I'm trying to stay away from calculator tonight because I don't have any reasonable expectation that everybody got the calculator. And if you're going the Amazon route, even if you ordered it right after class on Tuesday, there's no guarantee it got here. So, although some things do come pretty quickly. I ordered something on Amazon last night, and the doorbell rang before I left for here. And I was like, this is crazy. Some things do actually come fairly quickly. But it wasn't a UPS person. I don't know what the story is now. It was just some random schmo.
Amazon took the contract from most of the big companies, so now doing it on their own.
So is it like Uber? Like Uber Eats kind of thing?
Yeah, you go and you just buy packages, so they sell each package is $3, and you buy as many as you can do, and you do them. You can anybody, from your car,
that explains the quick turnaround.
I ended up getting the package like a whole white van, and I thought it was sketchy to have.
Yeah.
I was like, what the fuck is this?
Yeah, it was. They knocked on the door, and then, well, I have an electronic doorbell, not one of the Ring ones because I don't do a monthly subscription. I refuse to pay to those people, so I have one with internal storage, and so people knock on the door, and I'm like, oh no you don't, and I hit the button so that I can get them on camera. I'm like, you're not gonna like sneak up and get around my security devices. And then I see some, again, random schmo with a package. I'm like, I just figured it was some neighbor I didn't know, like they accidentally delivered it. We got a package for you. I'm like, who the hell are you? I'm like, get out of here. But give me my package first, so here's something. But yeah. That has nothing to do with this, but it's fun. So measures of central tendency it's a concept that you've seen before. You might have known, I don't know how often you call it the mean, you probably refer to it as the average. But the thing is, average is a tricky term, because if I were to say, I'll tell you what your average is in a course, or your grade point average, or basically anything that's got the word average in it. It could, or Dow Jones Industrial Average. It does not mean that it's a simple mean, right? It's not a matter of what we're going to do here, taking all the values in a data set, adding them up, and dividing by the number of values in the data set, all right? So, but the average that we're talking about here is, in that context, just that, all right? But, and in fact, under normal circumstances, I wouldn't define, like if I were writing a textbook, for example, I would not define the mean as the average of anything, all right? What I would do is define it in this fashion, where x bar is equal to the sum, of all the x values on the interval of I equals 1 to n. It's a very, very lovely looking expression, divided by n. All right, very, very complicated looking expression, but most people know when I say the average that what I mean is take all the values, add them together, and divide by the number of values in the set. What this is telling you to do, the top anyway, is add up all the values. This is the number of values in the set. This symbol represents the sample mean. All right? Because there's more than one type of mean. There's a sample mean and there's a population mean. It depends on what you're trying to find the mean of. All right? If the mean is related to a subset of a population, then it's a sample mean. Right? So, subset of a population. Well, a population, and we'll formally define all this stuff later, or later as in later in the course. But a population is defined as all of a particular category. All right? So, if I'm talking about the population of statistics note packets in my class, I'm talking about all of the individual note packets in the class. All right, and so maybe I want to find the average weight of those note packets. All right, which is a weird thing to want to do. You wouldn't think that that would be a reasonable thing to want to find the value of. But if you think of it as a form of quality control, to say, well, if I can find the average weight of all the packets, then I'm getting a sense of what the packets should weigh on an individual level. All right, so if any one packet weighs more or less than that number, then I could draw the conclusion that something went wrong with that individual packet. Maybe they didn't copy out enough pages, maybe they copied too many pages, or maybe what happened in one of my classes today, they stapled multiple packets together. You know, like, do I want to do all those calculations to figure that out? Probably not. But that's an example of how that can be a valuable piece of information. When you're finding the mean, you're finding something known as an expected value. All right, I thought I saw a hand. Was there a question, sir?
You said population is all of a particular
Category. All right, so a mean being an expected value is what, I mean, it kind of sounds like what you would expect, pun thoroughly intended. Yeah, it's what you would expect to be the value for a particular circumstance. All right, so in industry, these things happen all the time. You know, like, I mean, I'll tell you right now, I'm not weighing my unit packets to make sure that they have the appropriate amount of pages. What I do is I roll the dice, I hand out the packets, the warehouse prints them up, I hand them all out to you, and at some point, one person, two people are gonna let me know that a page is missing from the packet. And then I'll find I'll make a copy of the missing page and I'll give it to you. That's the easier way to go, right? But if you're producing something in mass, you know, mass quantity, then you need a quick and easy way to make the determination of whether or not you're meeting the expectation. All right, so, you know, just think about like producing candy. You know, the classic thing with statistics always comes down to M&Ms and Skittles. You know, for whatever reason, it's like you could teach an entire course with M&Ms and Skittles because you get the probability, but you also have the expected value. All right, so they don't sit there and count up the little M&Ms by hand and put them into the little bags and then zip them up and then send them out. They do it by weight. Now, mistakes can be made. So if they're telling you that the net weight of a bag of Skittles or a bag of M&Ms is supposed to be whatever, but then it turns out, you know, like you get a bag of those M&Ms on Halloween or something, and you're like, oh, this seems like a lot less than what I should have gotten. You know, it's probably because there was an error, right? And so what happens is that they allow for an acceptable amount of error, but that's determined by statistics, all right? So all of that should be at least somewhat of a motivating factor, or motivator is fine, to understand why this stuff works the way it does. Now, mechanically, you want to get stuff right on the test? You could say, all right, this guy's blabbing up there, but doesn't that just mean add up all these things and divide by 6? And I say it sure does. And I almost wrote a 7. All right, and so I'll just jot down a little X bar next to that. And then we'll use a calculating device. You know, it doesn't have to be anything fancy to figure out what the numerator is. I still calculator emulator that I bought. It's well, the app is called Graphing Calculator, but it's the free version of it is the X84. You can get that at the App Store. It emulates the graphing calculator, but it doesn't have all the functionality of it, or some of the functionality is a little bit different. So, you know, I'll have to kind of talk my way through some of it. But if you do have the graphing calculator, the TI-84, one of the things you could try to do is alpha y equals, which brings up a fraction toolbar. All right, but like I said, I don't have the expectation that people have these graphing calculators yet, but this is kind of a nice feature because in the TI-84s, if you do this, it'll reduce the fraction for you. All right, if it can be reduced, it'll do it. It also allows you to not have to worry about the bane of the existence of most math students everywhere, which would be the parentheses, or forgetting said parentheses. 6.0. I mean 6 really, but I'll put the 6.0 in. One thing that you'll learn in this course more than anything, or any other math course, is that data entry is critical. You type in the data incorrectly, you got the problem wrong, and that's it. Sometimes I can kind of flesh out in what way you got the problem wrong. Like, oh wow, you must have typed in this instead of that. So okay, I know where you went wrong, so at least I can give you most of the credit. But there are some instances where like, the number's not even close. I have no idea where you went. I can't give you anything, you know? So in those instances, when you're using the calculator to do the work for you, if you're unsure, unless you're like absolutely positive that you did it absolutely correctly, write a little description of what you did in the calculator, just to give yourself that partial credit. All right. So I'm going to take a second here, double check. Yeah. And so we get that measure, which can be converted into fraction form, but we don't really need to, because the original values were given in decimal form. So our answer could be given in decimal form too. All right, so the rounding convention that we use in this class is 3 significant digits. So most of the time that means 3 decimal places. All right. So, you know, like why 3 decimal places? It has to do with the level of error, acceptable or unacceptable error. So it turns out, and we'll do the math for this. It's kind of interesting, and you'll see what I'm talking about. But it's later in the course. There is a significant difference in the amount of estimation error when you round from 2 decimal places versus 3 decimal places. But the amount of estimation error that you get when you round 3 to 3 decimal places, 3 significant digits versus 4 significant digits, is negligible, right? To the point where it's infinitesimal, like teensy tiny, almost 0. All right, so barely any error when you round to 3 decimal places versus 4. Unacceptable amount of error when you round to 2 decimal places versus 3 decimal places. So the sweet spot is 3 decimal places. All right, so that's where we're at. All right. So, and again, you didn't need a fancy calculator. You didn't need a graphing calculator for this. You could have used a calculator on your phone. All right, so it's just adding and dividing. If you're worried about maybe order of operations, break up the steps. Add the numerator values, get an answer, then divide by the 6. All right. Now the median is, well, you know what, I'll preface all this by saying that once you all have your graphing calculators, I'll show you how to do this stuff on your graphing calculator in such a way that you won't have to do any real work, all right? So, like what we just did to find the mean, you won't even have to do that. The only thing you'd have to do is enter the data into your calculator and then tell the calculator, give me the summary statistics. Summary statistics are basically everything that we're learning about here. The mean, median, mode, the range, the mid-range indirectly, and something called the standard deviation. All right, so a lot of useful information that you can get right from the calculator, but this is just showing you where these values came from. The median is the middle value in the data set. So you put your data in ascending order or descending order, does not matter. It's just what we're going to use this for sort of requires that it be in ascending order. So that means smallest to largest. All right. There's a shortcut to that, but the shortest cut to all this is typing it in your calculator and let it do the work for you. So we're at the point where it's like, well, why bother with the by hand shortcuts when the big shortcut is on the horizon, right? So smallest value looks like a 1, then we got a 2, 3, 4, 6, 8, 9, and 14. Looks like it. Oh, I'm off the screen? Oh, there it is. Thank you. 24. All right, and so then all we're going to do is count to the middle. All right, so I use the cancellation technique. So it's not really anything too crazy, but when I'm counting, I just mark off the things that I've counted, just so you, like this, I can point to stuff, but it doesn't really do anything. All right, so that's not a highlighter, so that's not going to do much. Oh, that's the biggest highlighter, we're good. So counting inward, 2, 3, 4, and then whatever the middle term is, that is still the highlighter now. Whatever that middle term is, that's going to be your median. All right. So the key ingredient is the data has to be arranged in ascending order before you start the counting inward part of the process. All right. And again, we do the same thing with the next one. Zero. Ah, 2 2s. Aha. I really have no excuse. I've been using the same lesson for the last like 20 years. I mean, that doesn't mean I guess I should have it memorized or anything, but I should remember little things like that. All right, so I'm still going to count inward. Use green this time for those keeping score at home. So 2 terms, 3 terms. But then in this case, you have 2 middle terms. I still want the middle of the data set. So I want the value that's in the middle between these 2 terms. All right, that's where my median is going to be. All right, so off on the side, what I'm going to do is I'm going to take the average of those values. I'm going to add them up and divide by 2. These 2 entries, the 2 and the 3. There's 2 values, so I'm dividing by 2. All right, so 2 plus 3 divided by 2. Well, you're really just splitting the difference between 2 and 3, right? So 2.5. You can say 2.5, 2.5. You could leave it in improper fraction form. So add the 2 and 3, you get 5. You just write it as 5 halves. There's really no wrong way to represent an answer except to say that if you are rounding, you have to use the proper rounding convention. And that is to say that you round it to 3 significant digits. Now, if it naturally terminates after 1 digit or 2 digits, then you don't have to force it. I don't have to write this as 2.500. Yeah. Just 2.5 is fine. But if it were 2.517834, I'd have to round it. All right. The mode is most frequent value in the data set. All right. So, you know, I make the little notation there, can also be more than 1 or none. All right. So you could have 1 mode, you could have 2 modes, you could have 20 modes, or you could have no modes. All right. So you're just looking for the most frequent value in the data set. So mode, in the case of example A, would be what? 7. All right, what about B? None. All right, just be careful. You don't want to write 0. All right, you write 0, you're telling me that the most common number is 0. All right, and that's not the case. I don't see a 0 in the data set. All right, what about the third one? 1 and 3. And what about the last one? Just the 3, yeah. All right, we want only the most frequent value. All right, so just because a value repeats doesn't mean it's the value that we want to include in the mode. All right. Next up is the range and the mid-range. The range, very simple. It's just the difference between the highest and lowest value. So you have a high number in your data set, which is a 17 in this case, a low number, which is a 1, subtract them, and that's your range. It's the overall length of your data set. All right. So, what does a range give you? It gives you a sense of scale. It gives you a sense of how, if you're going to display your data, how you should go about doing that. You know, like if I'm going to set up my axes for a graph, how far out should I go? That's one application of it. There are others, but that's a pretty significant one. The other one's mid-range. That's less friendly. It's not difficult, but that doesn't stop half the class from getting it wrong on the test. Right? And so the reason behind that, so that being said, put an asterisk next to that one for a couple of reasons. One, because it's going to be on a test. And just so you know, before every test, they give you a breakdown of what's going to be on the test. Like question 1 will be this type of question, question 2 will be that type of question. So there's no surprises. But what happens is you go into the test, you tackle all the problems, you're confident with most of them. Maybe there's 1 or 2 that you're like, not really too sure about. Then you get to the mid-range question. You know that the range is the difference between the highest and lowest value. You didn't study the concept of mid-range, so when you get to that question, you're like, oh, I didn't study it, but, well, the range is 16. Mid-range, probably half of that, so you put down 8. Problem is, that's not what it is. Right? It's a middle value in the data set. It's a measure of center. It's a location more than anything else. All right. So really what's happening is you have, and I'll just draw a quick number line. You have a start value at 1. You have an end value at 17. The range is the distance from 1 to 17. All right. The mid-range is a location. So range is a distance, mid-range is a location. Now, if you have a lot of experience with function-based math, and what I mean by that is your college algebra, your pre-calc, calculus, anything like that, then you know range to mean something else. Domain and range. It's something else here. All right. So range here does not mean the same thing as range there. There is a significant amount of overlap in terminology between this course and other math courses. It's just that's not one of the overlaps. It's just not. All right. So if I want to find the location that represents the mid-range, what I'm looking for is the midpoint between the start and the stop. All right. So I'm looking for the midpoint between 1 and 17. The way I'd figure that is by adding 1 and 17 and dividing by 2. So I'm finding the average of 1 and 17. All right. So that gives me the middle value on the interval from 1 to 17. So 18 over 2 gives me a 9. Now, I take no joy in deducting credit when people give the wrong answer for the mid-range. I really don't. Honestly, my life is always going to be easier if everybody gets good grades. It's just how it is. Nobody complains when an entire class gets an A. Like everybody in the class gets an A. I had one time at the high school, I thought I'd get not in trouble, but I thought somebody would be like, "Hey, what's going on there?" I had 98, 97, like alphabetically, 98, 97, and then 100, 100, 100, 100, 100, 100, 100, 100 for marking period. And then like 89, 91, but there was that stretch of 100s where I was like, somebody's going to look at this and be like, are you just giving them away? No, they were just good students, you know. They did all the things I asked them to do, and that was fine, you know. So I have no problem giving the grade as long as it's earned. And in fact, in this class in the fall, like I said, like half the class got an A, but it was like a streak of them, A. I'm like, oh boy, can we like spread them out? Can you like change your last name to start with a different letter so I can at least break up that streak so it doesn't look so obvious?
You actually do get A, B, C, D.
Yeah, just like,
And it's just like, don't do that.
yeah. And I just imagine that, like, no matter how I would do it, if I were to like randomly do it, somebody would reorganize and it'd be like all the A's, and it's like it just stood out. Yeah, so like I don't want to take off the credit for this, and what's really going to be aggravating is the mid range is 8. I'm sorry, 9. Incorrectly, if you were to accidentally do it the wrong way, you'd come up with 8. And you'd be like, what's the big deal, man? It's like right there. But you didn't demonstrate knowledge of the content or concept. Either way, both words work. Right? So highlight this piece of information. I'm not going to say it's the most valuable question on the test. I'm not going to say it's the most important concept on the test. It's just a point that you don't want to throw away. Right? Let's try not to throw those away, and you're going to be in good shape. Right. It's not your first math class, you know. It's always the careless errors. And they really got to come up with a better name for that. Because it's not like you didn't care when you made the error. You're not sitting there being like, who gives a crap? I'm not going to put the units. I'm not going to label this graph. It's like, crap, I forgot. A forgetfulness error. I don't know, it doesn't roll off the tongue quite the same way. A silly error. Nah, stupid error. Oh, I thought you said stupid error. I'm like, yeah, that works too, you know. Human error, yeah. So, outliers. Outliers are hugely important. All right, so this is the reverse of what I was just talking about, where I was saying that the mid-range is like one of those concepts where you don't want to throw away the point, but it's not the most like earth-shattering concept. But outliers are. It's like fundamental to statistics. If you identify outliers in a data set, they have to be handled appropriately. But the first step in doing so means that you have to identify the outliers. Right? So you have to identify what value is so far off of what is appropriate within that data set that it sticks out like a sore thumb. Context is a good resource when it comes to that, because in a lot of cases you look at just the background. I know everybody loves word problems in math classes. It's just the way of it, you know. Like, forget the procedural stuff. Yeah, solve equations, x equals this. Oh, bring on those word problems. That's where it's at. I like to contextualize and visual. No, it's the opposite. But in this class, the word problems are going to help you get a leg up, because I might look at this data set and say, I don't know if there's an outlier there. I mean, the definition, any value that falls outside the range of blah. Look at that thing. Everything that we learn in this class will have a calculator shortcut, right? So this is no different. Nasty formula, I'm going to show you a much easier way to do it, but again, let's learn the ins and outs first, all right? So this problem has no context. Determine if the following set consists of any outliers. There's just some numbers there. I mean, the 42 is a lot bigger than the rest, but I don't know. If the context is, here's a set of values on the interval of 1 to 100, well, they're all appropriate, all right? But now throw a little context in there, all right? Students were selected randomly from a local elementary school, and their ages were listed below. Context. Like, I don't have to do any math now. That 42 shouldn't be there. I'm not even sure the 2 should be there. All right? I mean, you can make a case, I guess, for the 2 being there. Maybe bring your toddler to school day. I don't know. But the 42, I mean, it could be a Billy Madison sort of thing. That joke doesn't land as much anymore. Like when I first started teaching, they're like, "Oh, Billy Madison, what a great movie!" And then now it's like, "Oh yeah, that's the one with, is that Ben Stiller in that, or is that?" Okay, you know, good. So that's the thing. Like people just don't know. They just don't know. Should watch that though. It's a good movie. Happy Gilmore, obviously the better of the two, right? We all agree on that. Yeah. Right, so that's good. We're all on the same page here. Ace Ventura 2. The hands went down. That's crazy. Ace Ventura, awesome. Ace Ventura, I like. Ace Ventura 2, I think, aged better. Ace Ventura 1, I think it aged quicker.
The second one, When Nature Calls?
Yeah.
That was the one, right?
Yes, and I quote that every single day of my life. I quote it even when I don't think I'm quoting it. Shakaka. So anyway, and I'll tell you, I can't walk past the canned tuna fish at Costco without saying "Bumblebee tuna, bumblebee tuna." I can't say the rest of it. It's very inappropriate. Homework: watch any of the movies that I just said. No, just do it, just so we could all be on the same page in terms of the movie quotes. I do like to drop the odd movie reference every once again, and I mean, it's not going to count for points or anything, but it does count for goodwill. I drop the movie quote, you recognize what it is, I become happier. And then everybody ends up being happier for it. All right. So we know what the situation is. We suspect that the 42 is an outlier. We don't know why yet, or how, whichever word makes more sense. We have that formula, though. That formula is going to help us mathematically determine whether it is an outlier. Now, context always overrides the math. That's something that is going to be entirely frustrating in this course, because it's a 4-credit math class. There's supposed to be math happening, like solve this equation, make that graph, label it, maybe make another graph just because your teacher told you to, and then solve another equation just for the hell of it, just and do it all over again. It's going to be more like, here's a set of data. What's going on with it? Draw a conclusion from it. And within that process, you will do some math, you will create some graphs, but then you're also going to analyze the context behind that data. I try to keep the context as universal as possible. I try not to skew in any particular direction. I will say that sports lends itself very well to statistics because the data is published and easily accessible, and it's transparent. There's no hidden agendas there. I mean, there's hidden agendas everywhere, but if somebody rushed for 1,300 yards, they can't say, rush for 1,300 yards, but, he still sucks. Like, it's not what it is. It's 1,300 yards, and that's it. The individual ran for 1,300 yards. And then you make a determination of how that stands relative to the other individuals who rushed, whatever that means. So the sports works very well, but the thing is, what sport are you familiar with, if any, on an individual level? So I could put a football question on every single test. You're like, oh, crap. I know everything there is to know about soccer, but I don't know anything about football. Right? Well, soccer, football, it's always. Because they're like, well, football is soccer. I'm like, not that football. Soccer, football, baseball. I hate baseball. Okay, there goes that one. Lacrosse. What's that? Like all these different possibilities. So I try to keep it as user-friendly as possible. So, like, I like to ski. Now, you don't necessarily have to ski in order to understand that a person has got a couple of sticks on the bottom of their feet and they're using them to propel themselves down a mountain at unsafe speeds. All right? That is pretty much what's happening, right? So I'll give you some times, you know, like it took this individual a minute and a half. It took this individual a minute and 45 seconds. And then you could say, well, I know less time to complete a trip means you got there faster, right? You don't actually have to have been a skier in order to understand that. And you could fill in the blanks. Okay, he's saying skiing, but I'm seeing sleigh riding. You know, like whatever it is, just fill it in your mind. So, but it does, the context will give you a sense of what's going on. So if this is the elementary school student, yeah, that 42 is not supposed to be there. Now, is it because there's a 42-year-old sitting in the class? Or is it because the individual who collected the data forgot to hit the tab after the 4? You know, 2, tab, 4, tab, 5, tab, 6, tab, 7, tab, 8, tab, 9, tab, 10, tab, 42. I forgot to do the tab between the 4 and the 2. All right, so it's supposed to be a 4-year-old and a 2-year-old. If there was an element of human error involved where they displayed the data incorrectly, and that threw everything out of whack. Right? It's kind of like when you, I mean, some of you have never done this, but so I'll say the collective you write down a problem, but then because your handwriting is such trash, you misread your own handwriting and write something that's completely incorrect, even though your first step was fine. Like that 2 became a Z for some reason. It just slowly morphed itself into something else. You know, it happens, you know. So we'll get into how we handle this, but the context is going to determine whether or not that 42 stays in the data set or gets removed. We know it shouldn't be there, but honestly, if there really is a 42-year-old student enrolled in that class, then this data set is appropriate and that outlier should not be removed. If somebody forgot to hit the tab after the 4, then that's an incorrect data value, and it should either be corrected, like if you can pinpoint and say, okay, they did not separate it, it's supposed to be a 4 and 2, you're absolutely sure that that's the case, then fix the data. If you're not, take it out, play it safe. All right. So, how do you find the outliers? Well, we got to talk about these values. All right, we got an LQ. We got a UQ. And we have an IQR. The LQ is the lower quartile. Now, regardless of the fact that we're going to eventually learn how to do this stuff all on the calculator, you still want to know what each of these things represents, right? Just because it will play a role in how we do things. All right. That lower quartile can also be symbolized with a Q subscript of 1, which means the same thing as the first quartile, which is the same as the 25th percentile. All of which I'm going to write in a second, but I want to write the beginnings of the next one first. All right, so upper quartile because I don't want to scroll back and forth. So UQ is the upper quartile, also represented with a Q sub 3. The Q1 again represents the first quartile. The Q sub 3 represents the third quartile. The first quartile and the third quartile, you know, you're thinking in terms of quarters. 1 quarter, 25%, 3 quarters, 75%. So 25th percentile, 75th percentile. All right, so a natural question would be, well, what about all the other percentiles? What about the 50th percentile? Well, we already have that. It's the halfway point. That would be the median. All right, so we already have that. The 0 percentile, that's the start point, and the 100th percentile would be the end point. All right, we don't need any of those values for what we're about to do here, but you know they're going to be useful down the line too. All right. The IQR is something called the interquartile range. All right, so interquartile range, and it's just the difference between Q1 and Q3. So you could say the difference between LQ and UQ, upper and lower quartile. Oh, sorry, I wrote it backwards. Like a friggin' noob here. This is crazy. Q3 minus Q1. It's the whole walking and chewing gum thing. So it's the difference between the upper and lower quartile. And so what it does is it gives you a sense of where the bulk of the data exists. Now, not only before this is all over with, are we going to learn about measures of center, mean, median, mode, and all that good stuff. We're also going to learn about measures of spread and variation. So how varied the data set is or are. All right. Because really, I think it's just important to know how spread out a data set is as it is to know what the central value is. I go back to my classic airport example because, and it's, I kind of refreshed it a little bit. It's not classic anymore. It's brought into the 21st century because I just got the TSA pre-check, and man, that's life changing. If you haven't done the TSA pre-check, please don't. Because then you're going to be on the line too, and then it's like if everybody has TSA pre-check, then all the people that are on those line. What's that?
They have a third thing now.
Oh, like an upgrade. Oh, the world, the global
Entry.
Yeah, I got to do that. I got to get the enhanced driver's license too. I'm ready to re-up on my driver's license. I want to get that bad boy. So I get lots going on in my brain right now, but. The TSA pre-check thing, that was like just to reduce the variability, because back in the good old days pre-check, it was like, I mean, you're going to JFK to fly somewhere, depending on where you're going to go, it could be 5 minutes through security, or it could be 2 hours to get through security. I mean, it was like a complete crapshoot. So what do? You get to the airport 4 hours before your flight, and then you sit at the gate for 3 hours and 55 minutes. And you're like, this sucks, right? Or you're running late, or you just kind of roll the dice. Well, last time it took 2 hours to get through, so I'll do that. Or maybe you say, yeah, it can't possibly take 2 hours to get through. So you get there 2 hours before the flight and you miss your flight. I remember like 20 years ago, they used to go through the security line. They used to go through baggage drop-off and security lines. Okay, so the flight to Orlando's leaving in like an hour. If anybody's on that flight, come with me. You know, they're like, well, we'll get you on the flight. Like, you guys can wait because your flight isn't until this afternoon. Why you're here at 8 a.m. is on you. But like they would kind of get you through. Now it's like, oh, anybody here for Orlando? Yeah, your flight's leaving in 45 minutes. You're not making that. Go home. Catch the next one. You know, like they don't care anymore.
Quite 20 years ago, yeah. This was after 9/11.
Yeah.
Really.
That's when they start.
Just walk through with somebody.
Yeah. Well, that's the other thing. That's the other thing. I did not, and I still don't like it when they kind of mail it in on the security check. They're like, Oh yeah, go, go, go. And it was funny because I forget which airport I was at. I think it was yeah, it was in Hawaii somewhere, where they're like, all right, we're getting backed up here. Yeah, just go. I'm like, whoa, 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 whoa. Search that guy, and take me too. Like, you got to search somebody here. Come on, start doing the random checks. Let's do it.
My dad is always the one who gets picked for like the random spot check. Like everybody has to like the thorough.
Me too. I get it because I look suspicious,
He gets it because he's technically not a citizen of the United States.
and they just sniff that out.
Well, it's not his because he doesn't. Have,
Oh, so that you mean he's randomly selected,
He lives here, but he has a permanent green card.
right? But so when that comes through, when he goes through and talks to the guy, they're like, all right, have a nice day. Check that guy. So, yeah, that's the thing. But we reduce the variability by, making adjustments to plans. Like, I get the TSA pre-check, so my variability for security has been significantly reduced. I know that now, instead of having a window from 5 minutes to 2 hours of possible variability, it's now like 5 minutes to 25 minutes. So more predictable means that I can now plan accordingly, and that's a good thing. All right, so an interquartile range gives us a sense of the spread of the data. All right, so no, that's not what I wanted to do. All right, so it gives us a sense of the spread of the data. All right, so how do we find these things? Well, first we're going to identify the median. So we're going to count our way inward. Median is 7. And then we're going to find the median again, but this time for the lower half of the data set. All right, so I'm going to ignore that middle value, that median, and I'm going to basically treat the numbers 2 through 6. It's already in ascending order. I'm going to treat the numbers 2 through 6 as its own data set and find the median there. So smack dab in the middle between the 4 and the 5. So this would be my LQ, which is going to be 4.5. Then I'm going to find the median again. Starting on the high side of the 7, I have this set of values between the 8 and the 42. I'm going to treat that as its own data set and find the median of that set of values. So smack dab in the middle there would be 9.5. So 9.5. So there's my UQ. So LQ, UQ, Q1, Q3, it doesn't make a difference what you call it as long as you're reasonably consistent. So I'll say LQ, and I'll write that that's equal to Q1 again, is equal to 4.5. UQ is equal to Q3, which is 9.5. And IQR, Q3 minus Q1, which is going to be the difference between the two. And that's just going to be a clean 5. All right, so now it's what we do with that. All right, so our formula is bracket LQ minus 1.5 times the IQR, all of which we know, comma UQ plus 1.5 times the IQR. So 4.5 minus 1.5 times 5, comma, so it's two separate calculations, one giving us the low bound and one giving us the upper bound of what we're going to call the non-outlier interval. All right, so I'm looking at the UQ, which is 9.5 plus 1.5 times 5. And so, well, 1.5 times 5 is 7.5. So 4.5 minus 7.5 is -3. And 9.5 plus 7.5 is going to be 17. And so this is the interval of non-outliers. You could think of it as like the ordinary or expected values. The values that you would expect to see in the data set should be in this interval. Now, again, context is an overriding factor. Because if I told you that these are ages of elementary school students, and you saw an age of -3, you're going to think that there's something wrong, right? So the context tells you, all right, this says -3 to 17, but it can't be the negative values, can't be 0. It's got to be something bigger than 0. I suppose there could be an infant there. You know, like, what is the additional context? Are these students at the elementary school, or are they just people who are physically in the class in the elementary school? In which case the 42 could be okay, right? But what we get from this is the conclusion mathematically that therefore, and if you didn't know, 3 dots in the form of a triangle means therefore 42 is an outlier. All right, and so in every single data set, we are going to check for the presence of outliers. Now, you look at this, there's a fair amount of notes here, and I kind of wrote big. So you'd look at it and say, oh, okay, what's the real amount of work that you did? It's really not that significant. But if I told you, bless you, that you had 13 problems to do and you had to identify outliers for each one of them using this approach, you drive yourself insane. So we definitely need a shorter way of doing this. Sorry. Question?
So you know 42 is the outlier because of the 17.
Right, because this is the interval of good values. Any value that does not fall between these two numbers is going to be an outlier. So any number in the original data set that's lower than the -3 or bigger than the 17 would be considered an outlier.
So those brackets, they matter?
They do, because that tells us that these values are included in the set of non-outliers. All right, so if 17 was in a data set, in the original data set, that would be okay. All right. 18 is the first, assuming that they're all whole numbers, 18 would be the first bad value. The first value would be considered an outlier. All right. So yeah, that's where we're going to leave it.